Hi guys, so we have a question here still on number base. We have to convert 413 base 5 to octal system. Now remember not to be called 413. That's a decimal way of speaking. This is 413 base 5 to octal system. So we are going to go through two steps. The first step is to change this number from base 5 to decimal. So when we are done with changing it to decimal, we'll change it from decimal to octal system. So remember, an octal system is a number in what base? It's a number in base 8 system. So change step 1, we'll change to decimal. Change to decimal. So how do we change this number to decimal? Let us try to remember. We have a number in base 5, 413. All we need to do is to write it in its expanded form. So in order to write it in its expanded form, we need to know the placeholders, or which the value of each position that these numbers fall into. For example, this number 3 is in the unit place. This number 1 is in the 5's place, and this number 4 is in 25's place. So if you are still confused with how I'm getting this placeholders, you can watch my previous videos. So we said in indices form, the base remains the same, but the powers increase from right to left. So we have 5 raised to the power of 0. This one is 5 raised to the power of 1. And this one is 5 raised to the power of 2. So let me just change this to another color. And alright, so in expanded form now, we say 4 times 5 raised to the power of 2 in brackets plus 1 times 5 raised to the power of 1, good, plus 3 times 5 raised to the power of 0, good. So once we simplify this, we've gotten our answer in decimal or base 10. This will give us 4 times 25, 4 times 25 plus, and this will give us 1 times 5, and this is plus 3 times 1. Remember from indices that any number raised to the power of 0 is 1. If you simplify this, 4 times 25 gives us 100. And 1 times 5 is 5, 3 times 1 is 3. So this is 153 in base 10. So there's no need to write the subscript 10. Once you leave it without the subscript, everybody will know that you are in the base 10 system, because this is what we use. So the next thing to do is to change it to octal. Remember, that was the initial question, to change it to a base 8 system. So we use our method of successive division. A method of successive division goes like this. We are going to take our 153, we put it on one side, 153, and we are going to be dividing by 8. And we are going to write out our remainders. So we start by saying 8 goes in 153. It's quite big, so I'm going to say 8 goes in 15 first. 8 goes in 15 once, but I have a remainder of 7. I give that remainder to 3, and it is 73. 8 goes in 73 9 times, because I remember 8 times 9 is 72. So I write my 9 and I write my remainder of 1. I go again successively by 8. 8 goes in 19. How many times? From our multiplication table, 8 times 2 is 16. So I have just 2 and a remainder of 3. So I write my remainder. I will keep going. 8 goes in 2. 2 is not up to 8, so it cannot go in 2. We have 0 and we have a remainder of 2. We'll bring that 2 down as the remainder. So I take my arrow up take my arrow up to right, take my arrow up, something like this, to write out our remainders. So our final answer is going to be equal to 2, 3, 1 in base 8. Remember, we write the remainders from the last one to the first one, not the first one to the last one. So we have 2, 3, 1 in base 8. So we have another question here that is very similar, but in this case we are changing from ternary, which is a base 3 system, to hexadecimal. And if you remember, hexadecimal is in base 16. So very quickly, remember the first step is to change from base 3 to base 10. Once we get the base 10 equivalent, then we convert that one to base 16. So I'm write my number in expanded form. That is the method we use to change to base 10. And in expanded form, I write the powers. And what are our powers? In this case, the base is 3. So we go from 3 raised to the power of 0 to 3 raised to the power of 1 to 3 raised to the power of 2 to 3 raised to the power of 3. In this case, the previous question, it was 5 because we were in a base 5 system, but here we're in base 3 system, so it is 3. Then we write it out, we write the number out in what? In expanded form. And say 2 times 3 cube in brackets plus 1 times 3 squared in brackets plus 2 times 3 raised to the power of 1 in brackets plus 1 times 3 raised to the power of 0. And once I simplify this, 3 raised to the power of 3 is actually 3 in 3 places, which gives me 27. 3 times 3 times 3. So this is 2 times 27 in brackets plus, this is 1 times 3 in 2 places is just 3 times 3, which is 9, plus 2 times 3 raised to the power of 1 is just 3 in one place, so that's 2 times 3 plus 1 times 1. Remember, any number raised to the power of 0 is 1. So 27 multiplies 2 to give us 54 plus 1 times 9 is 9, 2 times 3 is 6, and 1 times 1 is 1. So once you simplify this, what do we get? You have 54 plus 9, and that should be 63. 63 plus 6 is 69, and 69 plus 1 gives us 770 exactly. Alright, so this 70 is in base 10, but we move to the next and the last step now is to change, using successive division, of course, to change from 70 base 10 to its equivalent in hexadecimal system, which is in base 16. So I'll drawn my line, and I'm going to write 70 on this side, and I'm dividing by 16. Remember, in this case we were dividing by what? By 8, because we were changing to an octal system. So I'll divide successively by 16. So how many 16s can we find in 70? That's the first thing. Now we know 16 times 10 is 160, 16 times 5 is 80, which is bigger. So I guess it has to be 4. It's 4, but there is definitely a remainder. 16 in 4 places will give us 64. So and 64 subtracted from 70 leaves a remainder of 6. So we'll write it out. So we'll successively divide. We'll say we'll go again. 16 goes in 4. It's 0. We can't find 16 in 4. So 0 remainder 4. And my arrow is going up again. Take my arrow up. Exactly. And just we start from the last remainder. So my final answer is equal to 446 base 16. Not to be confused with 46. Thank you for watching, guys.